Mr.
जी
Mayor.
सर.
Yes. Okay. So here this topic is basically projectile motion topic. So when we talk about projectile motion is the motion of an object into two dimension. Usually we call it that it is a two-dimensional motion. So two-dimension means something that is a body moves in forward as well as in the upward or downward direction. So forward to hai hai. Once you will throw a ball in the upward direction, yani in this way, so it is moving upward as well as it is moving forward. But when the ball will come down, it is still moving forward, but it is moving downward. So that is why it is called two-dimensional motion. So here I have explained some of the basic ideas about the projectile motion, that whenever you are going to throw or project a projectile, then it would be projected at certain angle. Let's say that at this projectile, whatever its mass is, because in kinematics mass does not matter, so it is projected at an angle of 60 degree rather, right? So 60 degree is basically the angle at which you have projected the projectile. And when you have projected this projectile, so its its velocity will be resolved into components, right? What will happen to the velocity? Velocity would be resolved into the components, and when the velocity is resolved, it is clearly mentioned that now this projectile has a component of the velocity which is compelling it to move upward, and one of the component is compelling it to move downward. So that is why when I used to talk about that, the velocity is resolved into the component. So one component is its x component, the one component is its y component. So x component is basically its v cos theta, or if it is u, then it is u cos theta. And then if we have its y component, it is your v sine theta, or simply say that it is vy and it is v sine theta. So you have to resolve these components by all means. Now the situation is this is v sine theta. If I say that it's without any resistance, the horizontal component remains same. There is no change in the horizontal component's velocity, but there is a problem in the vertical component. The vertical component goes to zero from maximum to highest point. For example, if you see at the highest point here, did you notice one thing, that at the highest point the object does not have any component in the upward direction, because its upward motion has been terminated, its upward motion has been stopped. That is why upward motion is ki khatam. So y axis पे motion velocity का y component भी नहीं होगा. So when there will be no velocity y component, then object would start downward motion. So this way I can resolve this, that it is your vy after some time, and this is your vx after some time. This is the same vx. So if I say that this is the vx after some more time, and now this is your vy, that is in opposite direction, and here it would be the same as that of the original one vy. So this is the entire discussion about your project, yeah, the paths of the projectile. So this is not the velocity time graph, it is actually the projectile's path. In that path there are two important factors. One is it's the range, we usually call the range of the projectile, and this is actually the height, the maximum height obtained by the projectile. So when we talk about this, here I have given you some examples, so with numeric values I will proceed further. Here the initial velocity by which you are going to throw a projectile is 12 meter per second. So that is why its component which is responsible for its horizontal motion, that is 6 meter per second, yani v cos theta. And that component which is along y-axis, it is v sine theta, so that is 12 sine 60, so it is 10.4 meter per second. So the vertical component, the vertical velocity of the projectile is 10 meter per second, 10.4 meter per second, and horizontal is 12 meter per second. Now I will just move onward. If the ball is taking 1.2 seconds to reach the maximum height, I will give you just simple descriptions and then I will move forward. The time taken by this projectile to reach to the maximum height. So how can I calculate the time taken? You know, the initial vertical velocity. Okay, one more thing, I want to add some points here which are not actually directly mentioned, because that is a revision, so I have to add these points. First of all, along x-axis no force. When there is no force, It means no acceleration. Is this clear to all? There is no acceleration. Physics number, no.
Okay.
When there is no acceleration, then velocity along x-axis remains constant throughout. Okay, that remains constant. It is not being changed. So when it is not being changed, it's very simple that the object would have a constant velocity kinematics or constant speed kinematics, because direction is also not reverse. So what do you think, what we learned when object is moving with constant speed? So we can use v is equals to d by t, or we can use that d is equals to vt equation. So whenever you are going to calculate the horizontal distance for the projectile, the horizontal distance is basically equal to what is the horizontal distance of the projectile? That will be equals to its u cos theta into time taken, right? This is basically the horizontal distance traveled by the projectile. Or in other words, you can say that if you want to now v cos theta, because u cos theta and v cos theta, they are same. So into time, okay? Is it clear to you?
Yes, sir.
Okay,
Yes.
but the problem is, yes, any confusion?
No, sir, clear.
Okay, but the problem is, I told you that the problem comes across vertical motion. For vertical motion, when we say for vertical motion, there is a situation when from throwing position, object has maximum velocity uy, which is equals to u sine theta, and at the highest point, uy or vy sine theta goes to 0, right? Here there is no vector at all. And then again at this point, when the projectile is dropped back, it is having a vertical velocity vy, which is equal to v sine theta. So during this all, yani if I just join the path of the projectile, during this all mechanism, the acceleration remains constant. G remains 9.8. That is what, that is the gravitational acceleration. So when I talk about gravitational acceleration meter per second square, it means that for upward motion, now I'm going to divide the motion of the projectile into two parts. This is its upward motion. Projectile goes up momentarily, it takes at it becomes at rest, and then it moves down. So here it has uy, here it has its vy goes to 0, again it drops down, and its vy is again non-zero, which is basically equal to v sine theta, right? But along x-axis it has a constant velocity, no direction reversal. So that is why it is vx, which is equal to ux, and that is equals to your u cos theta, or that is equals to v cos theta. Is this all description clear to everyone?
Yes, sir.
Is it clear?
Yes.
Okay. The problem is, the problem is, if we say that we have a sort of if we have to calculate the upward motion or only downward motion, so that is the accelerated motion. This is what I wanted to tell you after this all entire long discussion, that along along y-axis, the motion is accelerated motion, right? Do you believe this thing now? Motion is accelerated. So all the equations of acceleration will be used. So what equations of acceleration do we have? We have v is equals to u plus at. We have here, this v is basically vy, here it is uy, and that is equals to g times t. This is the equation which can be used along y-axis, one of the equations. Then the other equation, that is s is equals to ut plus 1 by 2 at square. Do you believe this thing? S equals to ut plus 1 by 2 8e square, is it? So this s is basically h, u is your u sine theta into t plus 1 by 2 gt square. No need to recall something new. Whatever you have recalled, that all will be used for your projectile motion. So that is what you, most of the time this is asked to you, that calculate the initial vertical motion, right? What to calculate initial vertical motion of the yeah, initial component of the vertical velocity. Then you will just think about that. Okay, problem will be solved. When problem will be solved, I will just uh, get into detail that the this equation will be used sensibly. Don't get in the trap of your quadratic equation, because here time is one, here time has two power. So what is trick or sensible technique to handle that? Because that initial velocity uy is equals to u sine theta, and vy is equal to 0. So whenever you are using that equation, during that acceleration is equals to negative, yani acceleration takes negative. So simply speaking, go ahead and use that. Your height will be calculated as h is equals to v minus 1 by 2 vt minus 1 by 2 gt square. This is another equation in which you can use negative sign and final velocity rather than initial velocity. So here your height is equals to vt is 0, just keep this factor 0, and 1 upon 2, g is negative, so negative it become positive, so it will become gt square. So 1 by 2 h will be equal to 1 by 2 gt square. That is the extracted form of this second equation. And for the third equation, when you are going to use third equation yani 2as wala equation, 2as equals v square minus u square, then the trick for that equation is it would become 2gh equals v square minus u square, where it is vy square and it is uy square. So I told you that for half of the motion of the projectile, for half of the projectile motion, one factor would be 0. So you can simply say 2gh is equals to, if this is 0, then it is u sine theta whole square, and definitely upward motion this acceleration would be taken as negative. So minus 2gh is equals to minus u sine theta whole square. So that would be gone, and you can again calculate height by this formula, u sine theta whole square divided by g. So divided by 2g. So there are several approaches which can be used to handle the projectile questions or projectile motion. Now I will give you another important trick, that is, the time matters a lot. The time of flight of the projectile, time of yeah, time to reach the maximum height, etc. So time calculations, the most important thing. For that one, if I just give you an example, that if I have a ball which was dropped from the table, right? That is a ball, and it is just dropped from the table. Its initial velocity is, let's say, 6 meter per second. Does it have some vertical component of the velocity here? Its initial vertical velocity is equal to 0. Just remember this thing. So when it will be dropped, it would make a projectile path, and it will reach to this point. Let's say this is your point B where it hits. Do you people hear me?
Yes, sir.
Okay.
Yes, sir.
So what is the game in this all? That is that if you say that this ball is going to hit this point at the surface, then as it falls down and down and down, its vertical velocity increases, and here the vertical velocity would become Vy. And one question, the time which is taken to reach, to drop this height, isn't it the same as the time to gain this horizontal distance? So this is the vertical time. TB is the vertical time, and this TH is the horizontal time. So can I simply say that vertical time is equals to horizontal time? Is this confusing or clear to all of you?
Clear.
Clear.
Okay. So when we say that vertical time is equals to horizontal time, so it means something, that mostly we can calculate the time from y-axis, right? This is one of the trick, that calculate time from y-axis calculations. And the y-axis calculations are really simple, that you will use either that equation of t is equals to v minus u divided by a, and here you now one of the component would be 0, vy will be 0. So the time is really simple, that u sine theta divided by g. This is the equation for the time. You can simply use this equation, that because this is the y component, y-axis, I'm talking about y-axis, so it will be u sine theta divided by g. So this time can be used to yeah, this is the vertical time. So as I told you, that this is the same time uh, to move this projectile, to displace this projectile along the x-axis. So you can simply use this to calculate x is equals to v times t. So you know what is v? V is v cos theta, r it is given to you, into time is u sine theta divided by g. So although it is u sine theta or u cos theta, it does not matter. So it is u square sine theta into cos theta divided by g. So there are so many equations. I can make number of equations for you, but just the trick is you have to use less number of equations for more functions. So here I go. I will just calculate each and everything for you. This is entire calculations. I will go back to that calculation, but before that, I want to give you one more concept. Time calculation clear to all of you?
Yes, sir. Yes, sir.
Okay. Now let's move towards the final velocity at any position. Final velocity at any position. When you have to find out the final velocity at any position, you know it has two components of the velocity. One is the horizontal component, that is ux or vx, it does not matter. And the second component is, what is second component? Vy or uy. Is it? Are you getting my point? This is while the body is just in the downfall. When the body is up, moving upward, can you see that at, let's say at this point, this component is its ux, and this component is its uy or vy? Does it make a difference?
No.
Only the resultant's direction is changed, nothing else. This is the resultant velocity after some time, and this is the resultant velocity after some time. So when you say that this is the resultant velocity, so we can simply calculate the resultant velocity. How? The resultant velocity can be calculated by using Pythagoras, that Vy square plus plus Vx square, that is equals to V at any time. At any time, you can calculate the velocity, find velocity by this method. Here again, either you have ux, yani whatever the horizontal velocity is, its square plus because it would remain same now. Horizontal velocity, why I'm using ux and vx simultaneously, because horizontal velocity does not change, but the only thing which changes, that is your vertical velocity. And vertical velocity you people can write in different ways, and here that is, what is the vertical component of the velocity? That vertical component is vy square and square root. So this is the final velocity after some time. In the same way, you people can be asked about the angle theta. So theta is nothing but the tan inverse of your vy to its u r vx. Simple. Whatever the velocity do you have at several time, you can take the vertical component divided by horizontal component and tan theta. So this is how you can use the for your information or your knowledge to solve the projectile questions. Then, as I told you, that there are graphs of the projectile motion as well. So for the graphs, you have one trick, that as the horizontal component of the velocity does not vary, so I can draw that in this way. Okay. Now, if you simply say that, let's say a projectile was having a initial speed of, let's say, 1 2 3 4 5 6. This was the initial speed of the projectile, right? The projectile what we were going to discuss. And let's say it takes 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Let's say it takes 8 seconds to reach the maximum height. So 1 2 3 4 5 6 7 8. This is the midpoint, this is the 8 second interval, and this is a 16 seconds interval. So what about the horizontal velocity? Yes, Mustabshir.
जी सर.
What about the horizontal velocity? The projectile was
सर
just
अगर एयर
thrown.
रेजिस्टेंस नहीं है तो
Nahi hai,
फिर
so
फिर
yes,
फिर
we are
कांस्टेंट
talking
है,
that
फिर कांस्टेंट.
that case. It would
यस
remain same. So graph
यस
would be this way, right? Is my point clear to all of you?
जी.
Okay. Then what was its vertical velocity at that time? 0. This is what? This is that case when the projectile was dropped down. This is that situation, right? Here you have dropped a projectile downward. So here its vertical velocity uy was equals to 0. Yani you can just cancel this one. You have only horizontal velocity along x-axis. So if it is so, what will you do? Yes, you will start your graph from 0, no worries at all. And at this point, it will have the maximum velocity by which it will hit the ground. So your graph would be here. Yani it depends whether it is 6 or more than that, because it is accelerating. So you can just calculate that and you can draw it, no worries at all. So this is your vertical velocity. Either you can say it u, y, or whatever. And after that, the projectile will drop down. So when the projectile is moving down, I mean, sorry, in this one, projectile will not move anywhere else because it will hit the ground. But on the same time, if you have a projectile which is being dropped in this way, which has this type of motion, for this type of motion, if it is being thrown by a velocity of, yes, 12 meter per second, then I told you that its horizontal component was 10.4 and vertical component was, sorry, its angle was 60 degree na? Yes, so it was 6 meter per second and this was 10.4. So at this point your vy would go to 0, right? But the other one would remain 6 meter per second. Here your vy would be minus 10.4, but your vx or ux would remain 6 horizontal velocity. So when you will draw the graph of this projectile, then you will have different situation, right? That situation means, let's say it is 2, 4, 6, 8, and 10, and 11, 12, sorry. This is 12 meter per second velocity, and let's say it is some time. So initially, the horizontal component is 6. So 2, 4, 6. So it is starting from here. It will remain throughout this way. But what about vertical? Vertical is at, from where the vertical is starting? Yeah, yeah.
Yes, sir.
From where the vertical component is starting, or what is the value of vertical component?
Thank God.
It is 10.4,
Good for yeah.
right? So it is 10.4. So your graph would be starting 6, 8, 10, 10.4 from here. And let's say in time t, suppose it is 1, 2, 3, 4, 5 seconds. Let's say it is 5 seconds. The projectile reaches to the highest position. Then in it will start from here. It will cut this axis at this point, and it would not stop here. It will continue with the same gradient. This is the beauty of this graph. It would continue with the same gradient. Yani its final speed would again be 10.4 meter per second if it is hitting the level, this point, the leveled surface. If it is dropped down, for example, there are some questions in which a projectile is thrown from a cliff, and that projectile is not hitting back to the hand. For example, a person is here on that cliff, and a projectile is being dropped from here, and that projectile is just dropped, dropped, and dropped. So this would have more velocity than initial one. Yani it has been dropped with certain velocity here. It is its initial position, and when it will hit, its velocity would be greater because it has reached more height. It has covered more height. So these type of questions are very important. You have to consider all those questions. So is this very clear to everyone?
Yes, sir.
Any confusion? Aban, Mohsen, Yahya, Mustabshir?
No, sir.
Okay, now the last calculation of your projectile motion is the calculation of displacement. Actually, when we talk about displacement, displacement is the shortest distance, is it? So shortest distance can be, for example, for a closed path till this point, what will be the displacement? The displacement would be equal to 0. Are you getting my point? So the displacement starts below this point. This is the displacement. Am I right?
Yes, sir.
So in this case, you can simply say that for all these projectiles, the displacement equals to 0. Displacement equal to 0. So if displacement equal to 0, area of upper part should be equal to area of lower part. Are you getting my point? This area 1 should be equals to area 2 for 0 displacement. Is this very clear to everyone?
Yes, sir. Clear.
Okay. Second thing I want to add in this entire game, that once you are calculating the displacement from horizontal and vertical, calculations are horizontal and vertical, what is that, distances, then that is a sort of Pythagoras theorem can be used simply. Okay. For example,
Yes, sir.
in this case, let's
Okay.
say, let's discuss about this case. Here, if a projectile is projected from point A to point B, then it would cover a horizontal distance, that is, let's say, 4 meters, and let's say it covers a vertical distance, distance or height, suppose it is 6 meter or 6.3 meter, whatever, then the displacement covered will be this shortest distance. You got that point? So from here, the displacement is equals to x square plus h square square root. Yani horizontal distance x, its square, and height is square. That will give you the total calculations of your displacement. Right? Is this clear to all?
Yes, sir, clear.
Yes,
So
yes.
these type of questions are asked to you, that why displacement is smaller than distance covered or the path length covered. So that is shortest distance, that is why it is a straight line distance, etc., etc. So this all is being asked to you in different ways, in different formats. For example, some from some questions, for example from some graphs, etc., etc. So I tried my best to give you as much detail on this small piece of slide as possible. Okay. So this is the part what I have already written. That is basically the numeric. Everything is there. Everything is there. Don't get scared of case sir told us something different here and that is some. Not, everything is same. Maybe the order would be different here and the order would be different on the slide what I have just written in front of you. But resolving of component is there, each and everything. But if air resistance is acting along, here is the game, new idea. In case of air resistance, what will you do? In case of air resistance, the motion would be just damped along x-axis. Yani along x-axis there would be deceleration. If you say that this was the path of a projectile which was without air resistance, then the object would have this type of motion, not curved inward, but it will have a sort of this way, right? Are you getting my point? Its height and range both would be decreased. Height and range both would be decreased. Okay, because along x-axis deceleration is yani resistance force is there. So due to that resistance force, the forward distance will be less, and along y-axis there is a resistance. That's why it would be now changed. The question is asked to you, what is the maximum height then? Will that be smaller than the previous one or less than? So you people can say that in case of, this is most frequently asked question, in case of air resistance, in case of air resistance, the maximum height is reduced. Maximum height is reduced. Please mention, I'm just going to mention this is asked in your past papers for last 2 marks. Maximum height is reduced, so it takes, yani it means the body or the projectile takes less time to reach that maximum height. There is one other reason which is most favorite of the examiner, and that is that as the object has retardation, so as the object has retardation or deceleration, has deceleration, so it will reach to maximum height quickly. Because what is the maximum height? The maximum height is the point where its final velocity goes to zero. Yani, to stop its vertical motion, it reaches to its vertical height quickly, or it stops it it stops its vertical motion quickly. That is why it comes back. This is the entire concept of your projectile motion. I hope that this every single slot would be clear to you. If not, we will practice the questions tomorrow, and then inshallah it will be clear to you. Okay, Ji?
Okay.
Any question till now?
No, no question.
Okay, I will send you these these documents. I will try my best to save them as possible if that would be exported in terms of PDF. Do you people have OneNotes with you in your mobiles, or
Yes, sir.
so I
Yes,
can
sir.
send this? Yeah, so it would be fine that if I send this file to you in terms of OneNote. Okay.
जी सर सही ठीक है
Okay. So here we go. Yes. Desktop. Okay, desktop. Yes, OPG. Just a second. Give me a second, please. Yes, just check this one out, that whether it is feasible for you or not. Oh my god. It is not imported at WhatsApp. Anyhow, I will manage to send you. Okay?
ठीक है सर
Okay. Inshallah. See you then.
अल्लाह हाफिज़ सर
Love
Yeah.
is. Please come up with practicing
Mm.
stuff tomorrow. Please.
Okay, sir.
Okay? Come
Okay.
up with your problems, and we will discuss those all projectile motion.